An 8-cylinder 4-stroke diesel engine of 229mm bore, 304mm stroke, and compression ratio of 14:1 has an output of 375 kilowatts at 750 revs per minute. The volumetric efficiency is 78%, the mechanical efficiency is 90%, and the air flow ratio is 25:1. If the indicated mean effective pressure of the pumping loop is 0.3345 bar, calculate the indicated mean effective pressure of the working loop. B. The mass flow rate of air and the specific fuel consumption, given that the LCV of fuel is 44,000. The pressure of air is 1.03 bar, the temperature of air is 15 degrees Celsius, and the specific gas constant R is equal to 0.287. Yes. In the question, we've also given that our volumetric efficiency is 78%. Divided by 100, you have 0.78. Your mechanical efficiency is 90%. Divided by 100, you have 0.90. Air fuel ratio is equal to 25:1. And now, they said the indicated mean effective pressure for the pumping loop is 0.345 bar. Now, in engine performance analysis, when they mention your pumping loop, your working loop, and your total loop, your pumping loop means the loop involved with your losses. That's L, or let's say WL. The loop involved with your losses. Your working loop is the loop involved with your brake power, and your total loop is the loop involved with your indicated power. If the question says that the indicated mean effective pressure for the pumping loop, that is the pressure for the pumping loop, since the pumping loop is your working loop, the pressure for the pumping loop is your PL. So you see PL is equal to 0.345 bar. And we are solving for pressure in kilopascals. So what you're simply doing is multiplying your answer in bar by 100 to give you 34.5 kilopascals. Okay. Now in the question we are asked to find the indicated mean effective pressure in the working loop. So we are looking for our PD. What else are we asked to find? The mass flow rate of air, that is your mass flow rate of air. We are also asked, so as I was saying, the specific fuel consumption. We are also asked to find the specific fuel consumption, that is your SFC. So these are the three things we are looking for. Now, let's start. Okay. So, when solving, if you're giving your values for your L, your D, your K, and your S, I'd advise to look for your swept volume first, because we'll use your swept volume to solve a lot of things. So let's start. Solution. So let's see. Our VS is equal to L, A, N, K. That is your lambs. So now we can say that lambs now, since area is equal to.
That's your what volume?
What?
Swept volume.
It's your swept volume. Swept volume. Your VS is your swept volume.
Always find swept volume first. No matter what you're looking for.
Find swept volume first. It makes it easier to solve. So now, you now see your VS is equal to L times, open the bracket. Now the area of the cylinder is given as pi times V squared over 4 times your engine speed times your K times your S. We put this in, our L is 0.344 times 5 times 0.2. times your number of cylinders, the number of cylinders, which is 8. The answer will give you
0.626, sorry. Meters per cube
meter cube
per second.
second. Your unit is meter cube per second because you converted your length to meters. So it's meter cube per second. This is your answer for your step volume. Now, the question. In the question, we were asked to find this thing, mass of air, the mass flow rate of air. And I will now say, recall, write this down. Recall that density is equal to mass. To get mass, you can now rearrange it to make mass of the formula and say that density is times volume. Therefore, the mass flow rate of air is equal to the density of air times the volumetric flow rate of air.
Yes.
The density of air was given in the question. Okay, so let's continue. So our density of air is not given. Now, let's recall that we have our PV is equal to MRT. PV is equal to MRT. Now, if we rearrange this to make M over V, which is density, subject of formula, divide both sides by RT. T cancel out RT. We have PV RT equal to M. Divide both sides by V. We now have P over RT is equal to M over V, and M over V is density. So you can now write that the density of air is equal to the pressure of air over the gas constant of air, the specific gas constant of air, temperature of air. So again, your density of air is equal to your pressure of air with your specific gas constant of air times the temperature of air. In the question, it was given that the pressure of air is 1.013 bar.
So that's phi is equal to P over RT is a constant.
Phi is equal to P over RT is a constant. You can add it to your formulas as P over phi is equal to P over RT, it's a constant for pressure for density. So again, the pressure was given in the question as 1.031 bar. To convert it to kilopascal, we multiply it by 100 to give you 101.3 kilopascals. Gas constant was also given 0.87.
Converting Celsius to do
Temperature was given 15 degrees Celsius. Convert it to Kelvin, that is 15 288 Kelvin. Okay? Now, we have our density. So we see the density of air is equal to 101.3 over 0.287 times 288. The answer will be
1.226.
226.
226, yes.
So 1.23. 1.23. This thing.
Times 1 point.
This is your density of air. So now, we have our density of air, but we do not have our volume of air.
We have volume of air. We've solved for volume of air.
No, we now restarted again. So I
Okay.
think we restart again. Okay, so let's say our volume of air. When I say that, recall to get our volume of air. In the question, we've already solved for our swept volume before, and we have our volumetric efficiency here. Let's do recall your volumetric efficiency is equal to the volume of air over your swept volume. If you make your volume of air, so the formula you're going to have, your volume of air is equal to your volumetric efficiency times your swept volume. That is equal to VA 0.78 times 0. What was our swept volume again? Swept volume is 66. 0.48. So you have your volume of air is equal to your volumetric efficiency multiplied by your swept volume. That will give you 0.48 meter cube per second. So now we have our volume of air and we have our density of air. We can go on to write that our mass flow rate of air is equal to the density of air times the volume of air.
Aru is the different than the gave in the question. Specific gas constant.
So 2 times 0.48 comes out with 0.59 kilogram per second for your mass of air. So we solved the first question, which is find your mass of air. Now, the second question here was find your find your brake pressure. That is the indicated mean effective pressure in the working loop. That is your PB. Now, in normal scenario, we already have our brake power.
Sorry, this PA. Sorry, density of air. Okay, go on.
Okay, no problem. So, again, as I was saying, we have to look for our brake pressure, the indicated mean effective pressure in the working loop. And remember, I said working loop means the loop in your brake power. That is your working loop. The loop concerning your brake power. That is the pressure in your working loop, or the pressure with your brake power is your PB. Now, we have to find PB. On a normal circumstance, we're going to do our WB is equal to PB times your lambs. We already have our PB, we already have our lambs, we have our PB. We could do this to find your brake power. But in this question, we are asked to use so many other variables like your mechanical efficiency and your pressure loss to find your brake power. So to do that, we are going to take the formula for brake pressure. We're going to take the formula for brake pressure as PB is equal to the density of air times the brake thermal efficiency.
What's the formula calling for?
I can explain it, but it will take time.
So I just need to know the formula. This
is another formula, a very complex formula for brake pressure. brake pressure is equal to density of air, open brackets, your indicated thermal efficiency times your volumetric efficiency times your LCB or your F4 ratio. Know this formula. If you want to understand it, means me I'll explain it to you later. But right now, just know.
Yes, PV is 2019 English. What are we finding now with this formula?
Now, okay. Now we have this formula. We have our density of air, we have our F4 ratio. In the question, we were given our
LCB.
LCB was given. We were given our volumetric efficiency. What we need is just your indicated, yes, your brake thermal efficiency.
But you said indicated.
What they want. Again. Recall, this is the only value of brake thermal efficiency, the only value that we don't have. And brake thermal efficiency, again, mechanical efficiency is equal to your brake thermal efficiency over your indicated thermal efficiency. We don't have our indicated thermal efficiency, so we can't use this formula. But we know that our indicated thermal efficiency is equal to our indicated power over Q. We know that Q can be gotten from MF times LCB. But now, even if we get that, what about our WI? Now we're gonna write, recall that WL is equal to WI WI minus WB. Making WI subject to formula, now say WI is equal to WL plus WB. You have your WL as WL can be found with PL times lambda. We have our PL. We have the value of solved for lambda already. We put our PL and lambda here. We have our WL. We use the brake power we have here. Put it into here. We will find our WI. We use our F4 ratio, which is F4 ratio is equal to MA over MF. MF subject to formula. MF is equal to MA over F4 ratio. Using this, we have our MA already, we have our F4 ratio here. You know that 25 is the one, the same thing as 25
Over 1.
over 1, which is 25. So F4 ratio is 25. We have our MA, we have our F4 ratio, we find our MF. We have MF, we have LCB, we will find our Q. We've already gotten our indicated power.
Where did you get MF? So how did you get MF? MF. Okay.
F4 ratio is equal to MA over MF. MF is equal to MA divided by F4 ratio. Now say we have our indicated power, we've gotten our Q. We get our indicated thermal efficiency, indicated power over Q. You put that into here, your mechanical efficiency, you have it from the question here, 0.9, and you've just found your indicated thermal efficiency here. You will now make brake thermal efficiency the subject of the formula and do brake thermal efficiency is equal to mechanical efficiency times indicated thermal efficiency, and you will finally have your brake thermal efficiency, which you will put into this question and solve to get your PB.
Yeah. Yes.
So should I do that now?
Yes, please, by all means.
So let's see. So now that I've explained that, let me write it down. Please, what time is it?
12. Yeah, 12.
12, okay. Yeah, it is by 1. The start of the charger. Okay, so let's start. Let's look for our MF first. So we say air flow ratio is equal to MA over MF, right? MF is equal to MA over our air flow ratio. That is equal to 0.59 over 25 or 25 will give us 0.024 kilogram per second. We have our MF. Now, from the question, we're given that LCV is equal to 44,000. LCV is equal to 44,000. In a question, if LCV is not given, assume your LCV to be 42,000. If LCV is not given,
Hello? Hello?
assume LCV to be 42,000. If LCV is not given, assume LCV to be 42,000. Okay. So in this question, LCV is given. Let's continue. So we say that our quantity of heat equal to MF times LCV, which is 0.024 times 44,000. That is 1,100 kilojoules per second. Okay. The next thing we will do now is, let's say we call indicated mechanical efficiency is equal to breakdown efficiency over indicated thermal efficiency, which makes our breakdown efficiency to be equal to mechanical efficiency times our indicated thermal efficiency. Now, we know that our indicated thermal efficiency is equal to indicated power over Q. We have our Q already, we do not have our indicated power. So let's say, remember, let's go up again. Recall that working loss is equal to indicated power minus your brake power. Your indicated power minus your brake power, making your indicated power so the formula you have your WL plus WB. Now you can say WL is equal to PL times Gamma. That is, your PL is 34.5 times. Your amount that you've already solved for before was 0.06. You now see that your WL is 21.6 kilowatts. Your WI is your losses, that is 21.16 kilowatts
Hey,
plus
come on.
370.
Matthew, come on. Okay. So
21.6 plus, this is your working loss plus your brake power. Your power loss was your brake power to give your indicated power here. That is equal to 300.
people should come and eat. Too much
6 kilowatts.
down. You're correct. The man got 4.
So what's the indicated thermal efficiency?
Is equals to WI
WI
over 2.
396.6 over 11. This is equal to
0.378.
0.337. I got 36, so let's just leave it at that. Yeah, it's okay. So,
People should come and
thank you.
yeah, I don't understand though. Who should be thank you?
I'll come. Let me finish this thing. My phone space is wasted. Okay, so we continue from where we were. So continue. Brake thermal efficiency is equal to mechanical efficiency times your indicated thermal efficiency. 0.90 times 0.36, which we got 0.325.
I thought you indicated mean effective pressure.
For walking.
Okay, pressure is P. Power is W.
So now we can finally go back to that formula that I gave earlier. P is equal to the density, open bracket, for indicated brake power, and the indicated velocity, LCV, all over your air flow ratio. Now give you the density of air, 1.29, 1.23, sorry. The density of air is 1.23 times 0.5 times 0.78 times 44,000 over 25. The answer would be 575.5 kilopascal. This is your PB.
Okay, that's all.
This is your PB. We have found our PA. The last thing we have to find is SFC. And we can see that
MF
SFC is equal to
3,000.
MF times 3,600.
The W is which one?
Now, when solving SFC, if they don't specify, look for your indicated SFC. Always use your brake power. If they do not specify, solve for your indicated SFC. Always use the W. Because SFC, there is indicated and there is brake. There is indicated SFC and there is brake SFC. The only difference is using indicated power or brake power. So, if you are asked to find your SFC, if they don't specify indicated SFC, always use your brake power. So this would be this would be MF. Let's see, that's 0.24 equals 0.23 kilograms per kilowatt hour. So this is the final thing we have to look for. That's the final answer and finish the question.